Do you like your tasty treats served cold? Desserts sometimes come with a cold pack to help keep it cool. Inside this cold pack is a frozen gel. Because of its low temperature, it produces a cooling effect by absorbing the surrounding heat when we place it inside this cake box or on my hand. Notice that the cold pack is a solid at first, but it has now melted into a liquid state because it has absorbed heat from my hand. The heat absorbed to change from one state to another is called latent heat. Just like this frozen gel makes my hand cold when it absorbs latent heat, buildings in the Marina Bay district depend on a similar concept to obtain chilled water for their air conditioning and other needs. The Marina Bay District Cooling Network is a centralized underground chilled water production system. It has chillers and chambers for producing and storing ice. As the ice in the ice tanks melt, it absorbs latent heat from the water, so the water cools down. I'm here at Singapore District Cooling, or SDC, which is 25 meters underground. SDC produces ice in these huge tanks at night when the price of electricity is low. When the ice melts, it absorbs lots of latent heat from the water in these pipes, so it gets chilled to a cool 4.5 degrees Celsius.
The ice supplements the cooling from SDC's chillers. And through these underground pipes, chilled water is supplied to other buildings in the Marina Bay district.
Leveraging economies of scale, the Marina Bay District Cooling Network helps to save costs for buildings in the district because they no longer need to have their own chiller plants for their cooling needs. This centralized cooling system is highly efficient.
That's right. The energy saved is able to power 24,000 3-room HDB flats every year. But more than the science and technology behind district cooling, our contribution towards global energy conservation and climate control is driven by a culture of inquiry and innovation, supported by a group of dedicated professionals.
Absolutely. Now, let's head back above ground so we can see another innovative cooling feature at SDC that involves latent heat. Behind this mirror curtain are SDC's cooling towers. They work based on the principle of evaporative cooling. Inside the cooling towers, droplets of hot water evaporate when they come into contact with air that is being drawn up by the fan. This cools down the hot water that did not evaporate in the cooling towers, and the cold water is collected at the collection basin. Now, I would like to leave you with a question to think about. Using ideas about latent heat, can you explain how the cooling tower cools down warm water?